Hi my friends, today I propose you a model and a simulation based on a story, a little story. Your boss has noticed that you are good at modeling and simulations. He is not an engineer but an architect, and he thought of giving you a work assignment to see how capable you are. He drew this picture on paper. You see the picture, and laid out the conditions that must be met. These are the conditions. They are very exactly as seen in this dimensioned plan. Remembering the theory of mechanisms course, you immediately told him that this is the synthesis of mechanisms. More than this, you made it clear to the boss that this is a 4-bar linkage, as in this picture. A lever is fixed and the other 3 are movable. All you have here are these 1, 2, 3 red lines, well dimensioned, okay, which represent the positions of this tray when these 2 levers are moved. Your boss has placed here 7.84 degrees, 4.52, and so on, but this is the same, 400, 400. Good. Let's start. Standard millimeters IPT. Start 2D sketch. This plane, line, horizontal, restart, sloped, restart, and also sloped. They are equal in length. And the length is 400. The center point is somewhere between these 2 slopes. Angles. This is 452. And the other is 784. 84. Left end of which is placed in respect of the center point. This is 95. The next one is 283, and the last one is here 429. The other direction is 117, and 77. Your boss is very meticulous, yes? Use dimensions, precise dimensions, fully constrained. Good. Finish sketch. I call this basic sketch. Basic sketch. Okay. Now we create another sketch in the same plane, XY, where we project these three lines. 1, 2, 3. Then we make the previous sketch as not visible. These lines are yellow, so I apply Alt Fi to change the color of the background. High contrast. Okay. Now we see better that lines. They are not movable. They are fixed here. Now I select another color for lines in order to have a good image here, and I connect the left points of each and the other end points of that fixed lines. This is one. Now I change the color in yellow to create the mediator perpendicular from the center point. I select the center point, I go along this line a while, and now Inventor knows that I want to create a perpendicular. Restart, center, and perpendicular. You see, I can place it here, right here. Why? Because I extend this line to the other one. The same for the other blue lines at the other end. This is the first, and restart from here to the left, perpendicular here. Now I extend these two and I go back to default colors for lines. Nice, very nice. This is the second sketch. Now the third sketch on the same plane. And we use another color, magenta. I project this endpoint and this endpoint and this line. Escape, hide, and we have this combination. Again, default, I draw one line is this one, and the other is this one. They are all dimensioned because they are projected and fully constrained. This is our work sketch. This is a lever, this is another lever. I place dimensions because I need to know I accept this kind of dimension. More than this, I activate driven dimension as by default. Then I place dimension without confirmation. I dimension also the positions of that points. I need this. And this one. To here. Now I make a room for all to be sure we understand this, and more than this I use expressions because I want to have names for the parameters D9, D12, D11 and so on. If you take a look here, parameters, you see all of them. If you don't have this tool here, I remove from quick access toolbar and I go to manage, to the tab manage, and I apply FX to see this. You have this tool here or placed up. Yes, you see now all that driven dimensions. We don't need to memorize them, we have names. Good. Finish sketch. Save it under the name work sketch. Then under the name lever left, save. Having this sketch, the lever left is this one. Its dimension is placed. Let me activate this. This is the left lever with dimension D9. Yes? Good. I hide this. Now we create a new sketch in the XY plane. And we draw a circle diameter 30, another circle, same diameter on the same horizontal. The distance between them is this one, D9. Yes. Dimension between the two circles, D9. Then we connect the two circles with horizontals. 1, 2, parallel, and we make them equal to be sure they are symmetrical. Trim and other circles 15 and another one equal. If you change one of them, both will be changed. And this thickness or distance of 15. Finish sketch. Extrude this, not inside circles, on 10 millimeters. This is steel carbon. The color is orange, and the name is already placed, lever left. Save. And save as lever right. Right. This will be not orange but olive green, and only the distance is different. Double click here. The other distance is D11. Good. D11. D11. Longer than the previous. Very good. Save and save as side plate. Side plate. We eliminate this first volume, delete, OK, and now we activate this sketch to be visible, and we create a new sketch on this plane. The side plate is rectangular, generally rectangular. Left side contains the center point. The other dimensions are as we want. For instance, here is 200 enough. this is 550, and the last is 540. They must contain these 2 points. It's important. Then I make some construction here as once the boss, your boss is special, he is me. Your boss is right, me. 40, I apply split twice, an angle of 45, a perpendicular on 45 is this. This line is construction. These 2 small lines are equal. This means we have a center. This dimension is only 50, and fillet of 40 to these corners. This is a fully constrained sketch. Finish sketch, extrude, 10, okay, and I hide this. Now we select this face for a new sketch and we place 2 points, 1, 2. They have their dimensions. Dimension, this is D13, to the center point is D12, the other one from the center point is D15, and on vertical is D14. Finish sketch, hole 15 through, okay, that's good. We keep the material, still carbon, but we change this clear override to be as you can see. Now I make something interesting. I change the definition of this sketch. Redefine to be on this plane. Why? Because this is the position selected by our boss. Now we create the shaft, new, standard millimeters, sketch, this plane, line, up, right, up, right, and close. Coincident midpoint, with midpoint, center point. Same vertical for these 2 points. Collinear these 2, and axis center line this one. Dimensions 15 is this, 5 here, and 10. External 20. And other are unknown, parallel, vertical, and so on. Okay. Revolve. Okay. Chamfer 1 millimeter and 1 millimeter. Okay. Material. Steel carbon. This is the shaft. Save as shaft. Save. And now the tray. New standard millimeters, X, Y, and a rectangle. This rectangle. I center it. I don't know why, but always this is a good habit. Dimensions 500 and 800. Finish sketch, extrude, symmetrical 50. Okay, this corners must be rounded. Okay, then I place here 2 circles at a distance of 400. This is 15, the other is the same, equal. They are on the same horizontal and both on the same horizontal with a center point. I draw a line between their centers because I want to make it symmetrical. This center point over this. The distance, as I said, is 400. Finish sketch. Extrude. One, 2, at 10. Then we apply offset of 5 millimeters to the inside. 5. Finish sketch, extrude, internal on 20, cut. Okay. Now mirror. What to mirror? The two small shafts. The plane is this one. You see the two small shafts, and then mirror for this cutted space about the plane XY. Yes? Okay. Material is also steel carbon, and this face is blue. Blue, well painted, and the other one is red. Okay, very good. Save as a tray. Having all these parts, now we can create the assembly. New standard millimeters IAM. I eliminate these components and I place the side plate as grounded at origin. Now again Alt F(I) to change the color of the background back to presentation. Okay. Then place shafts 1, 2, constrain, insert the arrow to the left to be here, and the other one the same. Okay. Then another place of the lever left and the lever right together. Open. Look at them. Constrain. Again, insert this on this, apply, this is left lever, and the other one right here. Okay, now I arrange them to be somewhere here because I place the tray. This is the tray. I constrain this, the base of this small shaft to be here. Apply. And the other one, not insert but mate, the axis and the center point, the center of the circle. Okay. Good. Now, from a kinematic point of view, which means without the application of forces, we can verify the operation of the mechanism we have just synthesized. This is nothing more, nothing less than our invention, my friends. Take a look. I can move this to another position and be sure that we can reach any position we want from horizontal to that 4 degrees and 7 degrees. I place this somehow. As you can see, I make an angle of 0, this solution, between this face and this small face. Apply, and now it is horizontal. This is not to be maintained, but it helps us to measure the start angle. We use measure with the key M from Monaco, and we select this face and this face. The angle is 5.81. Remember this, 5.81. Now the tray was implied here. I suppress this. Now we can check if the conditions set by the project theme are met. We use that angle of 5.81 by applying a constraint of kind angle solution first, angle 5.81, but you see that the direction is clockwise and the trigonometry is with counterclockwise, so that I place here minus. Between what is to be placed this angle? Between this face and this face. Nothing was moved, so that this angle is respected. Apply. Now we have an angle at the lever left, and we can apply drive to 50, for instance, 50 degrees, and we have this result. To have a surprise, we can change this with 110, and we see something interesting. You see? Our problem now is that we want to know if this movement is enough for reaching the angle values from the theme of the project. We have these angles, 4.52, 7.84. We are sure that if we reach this, then this is already reached. Yes? Let's see what is this angle? I place 80 and we see the result. Now let's apply measurement with M from the keyboard between this face and this face, not line. This is 7.95. What means this? It means that we obtain this angle and we cover all that ones. Yes? Good. There are many ways to find this. One of them is to use dynamic simulation, but this tutorial does not go dynamic simulation. I go back to the initial position. Okay, and now I can add these components to the other side. We can do this by using mirror, and I have to make visible the plane which I already used. This is the tray, origin, this angle. I make it visible, return, and mirror here. Components are this, all this, but not the tray, of course. What plane? This plane. Now we have to save these new components. They have MIR from mirror because they are correspondent with the other. Okay, I make this not visible. F6, and for you to be sure of our work, I apply again drive between these two angles, -5 to +80. As I mentioned, if you place here 110, you see interesting position. It can be used in other purposes if you want. Okay, that's all for today. Thanks for watching. Bye bye.